Good morning, everyone. Today, we will be discussing the case studies that will be referred during the system modeling or the object oriented design. So, in the last lecture, we have seen there are two approaches for designing, that is, function oriented approach and object oriented approach. So, function oriented approach was completed, and we were supposed to continue with the object oriented approach. Now, in the object oriented approach, we are supposed to make several diagrams or the models. So, we will be taking these two case studies, and with the help of these two case studies, we will be making all those distinct diagrams like context diagram, use case diagram, process diagram, activity diagram, sequence diagram, class diagram, state transition diagram, and all. Right? So for those different diagrams, we should have an example or a case study. So let's see what are these case studies. Here we'll be discussing two case studies. The first one is an insulin pump control system, and the second one is a mental health care patient management system. So what are these two? The first one, insulin pump control system. Insulin pump control system is, you can say, an embedded system. Let's see here. It's an embedded system. Embedded system means we have devised a circuit where all these components are there, and that is a device is being developed here which can be implanted either into the human body or it can be externally worn by the patient, right? Which keeps on continuously monitoring the blood sugar level. So let's see what are the basic features to this. Insulin pump control system actually collects the data from the blood sugar sensor and calculates the amount of insulin required to be given. Okay. First thing, that means we have to see what is the current blood sugar level from the sensor reading, and the proper insulin needs to be calculated. Calculation based on the rate of change of blood sugar levels. So we have to include the rate of change of blood sugar level. Signal sent to a micro pump to deliver the correct insulin dose. Safety critical system, as low blood sugar can lead to brain malfunctioning, coma, and even the death. High blood sugar levels have long-term consequences such as eye and kidney damage. So we can say it is a safety critical system. If not monitored, it may be fatal. So understood with the help of this architecture. Insulin pump control system. The first one, since it is a device, it has to be now operable. So it needs certain power supply. So we'll be taking a battery or a power supply here. Then we have to inject the proper amount of insulin into the human body. So a reservoir is taken here where the insulin has been stored. Now, the basic part is a controller. Controller, that is like a human brain, which is going to control each and every component or the parts attached to it. So the process starts here. There is a sensor. Sensor keeps on continuously monitoring the blood sugar level. Right? As it sends the blood fluctuation, it sends the signal to this controller. Right? Now, there is a display 1 and display 2. That means two displays are there. It displays the sensor reading here in both the devices. Now, why we have taken two displays? Maybe a time could come there is an error in display 2. So, we have an alternative for display 2, that is display 1. So, the reading could be read from here. Or if display 1 is not working properly, the other one is there to display the reading. So ultimately, this is what making our system robust in nature. We're trying to avoid the failure of the system. So controller sends the reading displayed in the monitors. Controller, as he gets the signal, right? So it raises an alarm to indicate that there is certain change, because it's not, if you're wearing a watch, you never keep on checking the time continuously for each and every second. So how come we know there is a change and it needs an immediate insulin injection? So it raises an alarm, right? If there is a major fluctuation, then we quickly see the monitor. Okay, fine, this is what the level is, but automatically at the same time What this controller will do, it sends the signal to this pump which is attached to the insulin reservoir. So what it will do, it will check the time with the help of this clock. Okay, what was the insulin dose given prior to this? That means the previous dose. Because between two consecutive like you say ingestion of the insulin, there must be an optimum gap, right? And a proper dose has to be given based on that. So we check the previous time when it was given, and based on that we calculate the proper dose of the insulin. Those commands are being given to the pump. Pump takes the insulin from the insulin reservoir, and there is a needle assembly where needles are being placed, because each time you're supposed to take a new needle because it can be infectious. So we will not be using the same needle again and again. So pump takes the needle from here and inject it into the human body immediately, right? So within no time, this system will help us to get the proper sensor reading and automatically inject the proper amount of insulin in the human body immediately. Else, if the system is not there, a normal procedure says you have certain symptoms, but you never recognize that it is relevant to the blood, fluctuations in the blood, right? So normally we take the medicines as far as we feel ki, okay, this will work, or we take it from any chemist and we take the medicines. When it not works, then we go and seek the appointment of the doctor. Maybe you get an appointment for the next day, or maybe after a few days, or maybe in the same day but in the evening, right? The time lapse, and we know that if there is a fluctuation in a way, you can say the high fluctuation in the blood sugar can be very dangerous to one's life. So we have to avoid this time lapse of getting an appointment or self medication and everything. So the system is actually avoiding that delay and trying to save the life of a person by injecting the proper insulin in the proper time, right? So this is what the system will be discussing for the system models. See the activity model. One of the model is activity model that we'll be discussing later also. A diagram. What we do here is, see, this bubble shows the start, while this solid bubble encircled with a circle represents the end of the process, right, or an activity. Now a square symbol here represents the entity, right? While this oval represents the process. So understand it this way. So when the activity starts, we have the sensor, blood sensor, right? We analyze sensor reading that we get from the sensor, right? So this is the process of analyzing the sensor reading. So sensor reading is nothing, they are simply the fluctuations in the blood. It doesn't give the value of the sugar, right? It is just the blood fluctuations that is being read by the sensor. So by analyzing the sensor reading, we calculate how much is the blood sugar. So this is an entity, you get certain output here, blood sugar level is being computed. Based on this blood sugar level, now we compute how much insulin needs to be given, right? Now, in order to compute this insulin dose, what is required? We must know the insulin log. That is at what time, how much amount of insulin was given. Remember, this was the clock that indicates, right? At what time the previous insulin was given, and the log can be taken from here, right? So we calculate the insulin dose that is required to be given now. So whatever insulin you have computed here, this is an entity. You have to store it in the log dose so that it can be referred in the next cycle. Now, once this is being calculated, we have to compute the pump commands, right? Again, see, जैसे ही हमने यहाँ पे control, we have identified the how much insulin needs to be given. We have to give the instructions to this pump, right? So this is what is being said. We have to compute these pump commands. So pump data is generated. Control insulin pump, right? So amount of insulin has to be taken from the reservoir based on these commands. This is what is control the insulin pump. It will fetch the insulin from the pump or the reservoir, then insulin pump, and then the needle assembly will help us to inject it into the human body. So this is what an activity model for insulin pump control system is, right? So this was one of the case study. Now, what are the essential high level requirements for the system? The system shall be available to deliver insulin when required. That means availability is important here. The system shall perform reliably and deliver the correct amount of insulin to counteract the current level of blood sugar. Okay, fine. Reliability is important. It's not that you have an low sugar and you're giving the medicine for the high blood sugar. It should work correctly. Whatever is the current scenario, accordingly, reliably, you have to get the proper insulin and give it into the human body. The system must therefore be designed and implemented to ensure that the system always meets this requirement. So you have to take care, that is availability, correctness, reliability, which are the major parameters of the system, and you have to design your system in such a way that these requirements are being fulfilled in your system, right? So this was the first case study. Now the second case study is mental health care patient management system. Though we have already discussed this case study during the requirement phase when we were working on user and system requirements, just a quick review to it. A patient information system to support mental health care is a medical information system that maintains information about the patients suffering from mental health problems and the treatment that they have received. So ultimately, the system is working for the mentally sick people, the problems they're suffering, and we're supposed to give the treatment to those patients. It is a sort of a government campaign where we have to monitor how many patients are there in a particular region, how many are treated, how many are undergoing the treatment, and everything, right? So most mental health patients do not require dedicated hospital treatment, but need to attend specialist clinics regularly, where they can meet a doctor who has detailed knowledge of their problem. Right? So, we are talking about the mentally sick people, but not so critical that they have to be admitted to the hospital. They can live freely as a normal human being, but yes, they have to be given the regular treatment and the checkups needs to be carried out. Right? So this is one of the second feature of the system. And to make it easier for patients to attend, these clinics are not just run in hospitals. They may also be held in local medical practices or community centers. Like, it's not that the hospital is at one centralized location, right? It can be distributed among different outlets that is being like you can say carried out in different medical practices or the community center. Like I said earlier also, let's assume this diagram. We say that mental health care patient management system server is placed here. So I assumed an example, say this is Doon Hospital, which is centrally located, acts as a server. But it is not necessary that every patient has to go to the server or the main hospital to get the treatment. We can have certain local clients or the clinics where this mental health care patient management system is also working out there. Like it is said, it can be run by different outlets. So we are calling them as clinics. So maybe it is an Indresh hospital. You can assume this to be in Max. This can be a Kailash hospital. That means which are geographically located in this region, that is Dehradun region. So one is a server at Doon hospital, centrally located, and these are at the outskirts, which is covering different geographical location of Dehradun. And we have a centralized database where the entire patient database is maintained here, which acts as a repository, complete information, their illness, their treatment, the doctor treating them, and everything has been stored here. Right? So this was like for the basic features of the system. Right? The mental health care patient management system is an information system that is intended for use in clinics. Fine. It is an information system, a database system. It makes use of a centralized database of patient information, but has also been designed to run on a PC so that it may be accessed and used from sites that do not have secure network connectivity. Right? So, okay, fine, it can be run on a PC also. While the local systems have secure network access, they use patient information in their database, but they can download and use local copies of patients' record when they are disconnected. Fine. So it has a feature that you can download the copy from the server of the patient information and you can refer to that. It's not that entire 24 into 7 connectivity to the server is required to get the patient's information. You can retrieve a personal copy of that. To generate management information that allows health service manager to access the performance against local and government target. Like I said, it is a government campaign, so we have to prepare the management reporting so that can be monitored with the system. To provide medical staff with timely information to support the treatment of patient. So we need medical staff also with timely information can be provided by the system to these people and they can properly start with the treatment within no time. Okay, so this was the organization of the system. Now, the key features of the system. First is an individual care management, right? Individual care management means clinician can create records for the patient, edit the information in the system, view patient history, etc. Means related to individual patient, the entire database has to be maintained in the information system. The system supports data summaries so that doctor can quickly learn about the key problems and the treatment that have been prescribed. So data repository means the entire database will be there. But when a patient goes to a doctor, he quickly wants to review what is the illness, what was the treatment given in the say last visit. So a summary could be prepared from there. We'll see with the help of a sequence diagram later how the summary can be prepared here, right? So we can fetch the summary, not the complete information about the patient, just to quickly provide the treatment based on his history. Second is a patient monitoring. The system monitors the record of patients that are involved in the treatment and issues warning if possible problems are detected. So the system keeps on monitoring the records of the patient. And if he finds there is certain warning, like patient monitoring could be like the patient has to visit the hospital or the clinic again after a month. Now he forgets because he's a mentally sick people, he's not aware of like he has to go and visit a clinic. He has an appointment for that, maybe the next day, right? So a reminder could be sent, a raise alarm could be raised in that case that you have an appointment. A message could be broadcasted to the patient or the relatives of the patient that this patient has to visit this clinic at this time. He has an appointment, right? So just a alert could be raised. So, third one is the administrative reporting. The system generates monthly management report showing the number of patients treated at each clinic, the number of patients who have entered and left the care system, the number of patients sectioned, the drugs prescribed, and their cost. Since it is a government campaign, I have said earlier, so we have to prepare these reports because this has to be worked properly. Another feature is privacy. It is essential that patient information is confidential and is never disclosed to anyone apart from the authorized medical staff and the patient themselves. So you're going to store all the information related to a patient, his personal, like you can contact number, maybe his bank details, maybe his PAN number, his Aadhaar number. So that has to be keeply. You have to securely store that information, and you never need to disclose it to anyone. So you have to implement all those privacies into your system. Safety. Some mental illness cause patient to become suicidal or a danger to other people. Whenever possible, the system should warn medical staff about potentially suicidal or dangerous patients. So safety is like for everyone, even for the patient himself or for the persons who are around him. So maybe a mentally sick people, maybe the worst condition could be he could be fatal to himself, like he could harm himself by injuries or he can be suicidal. So that safety has to be maintained for patient also as well as the doctors or the staff or the relatives whosoever is around him. You have to maintain that safety. The system must be available when needed, otherwise safety may be compromised and it may be impossible to prescribe the correct medication to patients. Simply we have to take care of the patient properly. So we'll be looking at one of the diagram which says involuntary detention of a patient where We taken decision of keeping that patient into a secure place like a hospital, maybe if the space is not available in the hospital, so we can keep him in the police station because he is fatal to himself or the others. So the system also works on this safety part of the persons whosoever is involved in the system. So this was all about your case study. So we will be discussing about the system models now from the next lecture. Thank you.